All right, day 3 of this week, we're doing systems of equations. Today we're going to do it with 2 quadratics instead of 1 linear and 1 quadratic. But before we do, Calvin's joke about basketball got me thinking of some of my favorite sports jokes. So the first one is, what's the difference between a dollar bill and the Raiders? A dollar will actually give you all 4 quarters. Speaking of the Raiders, do you know how Raiders fans count to 10? 0-1. 0-2, 0-3, 0-4. All right, anyway. If you didn't get it, it's all right. It means they lose a lot. Yes, that's right. All right, anyway. Solving with 2 quadratics. So similar to what we did yesterday, if we have 2 equations that both start with y, we can take one equation and we can plug it in for the y of the other equation. The only difference today is one of the equations is not linear. Today, both of them are quadratics. So when I plug this in, I get x squared plus 3x minus 5 equals negative x squared plus 10x minus 1. So I've got 2 sets of x squared, and that's fine. Our goal is still going to be get one side equal to 0. And I always want my x squared to be a positive. So since this one's already a positive, I'm going to keep it here and I'm going to move this negative over to this side. Be careful. Some people will see x squared and negative x squared and try to cancel them. But if we need to move a negative x squared, we actually have to add x squared to both sides. Right? So you're going to end up getting 2x squared. Same thing with plus 10x, we have to do minus 10x. So subtract 10x from both sides. And then with negative 1, we're going to add 1 to both sides so that everything on one side of the equation crosses out. And we're now left with 2x squared minus 7x minus 4 equals 0. So we have a quadratic equation equal to 0. Set up perfectly for our good old quadratic formula. Identify our a value of 2, b of negative 7, c of negative 4. And we're going to plug that into our formula. X equals negative 7 plus or minus the square root. Running out of room already. Negative 7 squared, which is 49, minus 4 times 2 times negative 4. So 2 negatives make a positive. And 4 times 2 is 8. 8 times 4 is 32. Minus 4 and C. Figured it out. I thought I made a mistake. I didn't. Okay. 2 negatives make a positive. 4 times 2 is 8. 8 times 4 is 32. Forgive me for the delay there. It's kind of like our internet connection sometime, right? And then we get going. All over 2a. So 2 times 2 is 4. And we end up with x equals positive 7 plus or minus the square root of 81 over 4. Well, square root of 81, thankfully, is a perfect square. And we get 7 plus or minus square root of 81, which is 9 over 4. Since we don't have any square roots left, we can go ahead and find our 2 separate x values. We can do 7 plus 9 over 4. And we can do 7 minus 9 over 4. So this one gives us 16 over 4, which is 4. So one of our x values is 4. The second one, I get 7 minus 9 is negative 2 over 4, which reduces to a negative 1/2, or I'm going to call it negative 0.5. So hopefully from yesterday you remember that once we find our x's, we're not actually done. That is just the first part. We know that our solutions are going to be the ordered pairs 4, comma something, and for the other one, our x value is negative 0.5, comma, something. Well, how do we find these two missing y values? Well, since we know the x value, we can take this and we can plug it back in to either equation from the start, and we can get the y coordinate that goes with it. So when I decide which equation to plug it into, I usually just pick the one that looks easier. And to me, this equation looks like it's going to be easier to plug into because there's no negatives. So that's the one I'm going to plug it into. So if I plug in 4 for x, I get 4 squared plus 3 times 4. Right? It had two different x's in there, so I put my first x there, my second x there, minus 5. So that's 16 plus 12 minus 5. As I go left to right, that gives me 28 minus 5, which is 23. So if my x value is 4, plug it in, I get a y value of 23. If I plugged 4 into this equation, it would give me the exact same thing. All right, the second one, I'm going to plug in negative 0.5. So I have negative 0.5 squared plus 3 times negative 0.5 minus 5. Sorry, it's a little sloppy here. If I do negative 0.5 squared, I know it's going to be a positive, and half of a half is a quarter, so this is 0.25. 3 times negative 1/2 is negative 1.5, and then minus 5. 0.25 minus 1.5 is a negative 1.25. And if we subtract 5 from that, we get negative 6.25. So these two graphs will cross at 423 and at negative 0.5, negative 6.25. Okay, shifting gears a little bit, let's talk about the different types of solutions we can get. The key on today is recognizing that both graphs or both equations are quadratics, which means when we graph them, both of them are going to be parabolas. So it's going to be a little bit different than yesterday when we had one line and one parabola. So if we have two parabolas, one option is for them to cross in two different places. And it can look a lot different than this. Both of them can actually be opening up and still cross in two places. They can both be opening down and still cross in two places. But this is one of the more common examples. So it's possible that we get two solutions. Is it possible for two parabolas to just cross in one place? Well, yeah. We could have one that opens up, and maybe we have one that shares the same vertex but is wider. These two graphs only cross one place, they cross right there. Or you could have one opening up, the other opening down, but it only touches in one spot, right? So both of those would be examples of graphs that would have one solution. Is it also possible to have no solutions? Well, of course it is, because I could have two parabolas that never touch. If these two parabolas never cross, where do they cross? Trick question. They never cross. So there are no solutions. But with quadratics, we actually get one more option. See if you can think of what that option is. Our fourth option is if we graph a parabola and our second parabola is the exact same parabola, how many times do those two graphs touch? Well, they are touching everywhere. That is an infinite number of solutions. So this is called infinite solutions. To be honest, we probably won't give you any of those, maybe one, but typically you're going to end up getting two solutions, one solution, or no solutions. But just know that it is possible, since the two graphs are both parabolas, they could have an infinite number of solutions. All right, let's do some practice. So solve the system of equations algebraically then verify by looking at a graph. So the nice thing about these is you could go plug these into Desmos and find where they cross, and you know what the solutions are. So it's a real easy way to check your work. But we do still expect you to be able to do the algebraic work and use the quadratic formula to solve it. We're going to ask you to do problems like that on our evidence learning. But again, to solve our system, I'm going to take one equation and plug it in for y in the second equation. So x squared plus 2x plus 1 equals 2x squared minus x minus 3. Now I want the x squareds on the same side because I want one side equal to 0. But I also want my x squared to be positive. So I always move the smaller x squared. The smaller x squared is the 1x squared. So I'm going to move it by subtracting it. And if I subtract it from one side, I subtract it from the other. And then same thing with the rest of the terms, right? Subtract 2x, subtract 1. And now I've gotten one side of the equation to cancel out. So it equals 0. And this side is going to be x squared minus 3x minus 4. And we are now set up with a quadratic equation in standard form where we can use our quadratic formula. A is 1, B is negative 3, C is negative 4. Plug it in, get to solving. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, so I get 3 plus or minus square root of 9 plus 16 over 2. Well, 9 plus 16 is 25. And as we simplify, the square root of 25 is a regular 5. And so we now know that our x values are going to be 3 plus or minus 5 divided by 2. Well, 3 plus 5 is 8. 8 divided by 2 is 4. So 4 is one x value. 3 minus 5 is negative 2. And negative 2 divided by 2 is negative 1. And there we go. There are x coordinates. Now, we are not done because what do we still need to find? We still need to find the y coordinate. So I know my solutions are going to be 4 comma something and negative 1 comma something. And to find the y coordinate, we're going to take our x and plug it in. Again, I can plug it into either equation. I'm going to choose the top one because it looks a little bit easier. And I get y equals 4 squared plus 2 times 4 plus 1. So y equals 16 plus 8 plus 1, which if I add all that together, that is 25. So we get the ordered pair 4 comma 25. That is one of our solutions. That is one of the spots where these two graphs will cross. My second one, I know my x is negative 1. So I'm going to plug it in. Again, I can plug it into either equation. I'm going to plug it into the top one because it looks easier. Negative 1 squared plus 2 times negative 1 plus 1. Negative times negative is a positive 1. 2 times negative 1 is negative 2. And then 1 minus 2 is negative 1. Negative 1 plus 1 is 0. So with an x value of negative 1, my y value is 0. So two solutions, that means the two parabolas will cross in two places. Let's see if I have that graph. I don't have that graph, but I promise you if you go and graph those two equations, they will cross or intersect at 425 and negative 1, 0. Okay, another example. We're going to use substitution. So I'm going to substitute this in for y. 2x squared minus 7x plus 6 equals negative 2x squared plus 5x minus 3. I want my x squared to be positive, so I'm going to move my smaller one. add 2x squared to both sides. Get rid of this by subtracting 5x from both sides. And to get rid of the negative 3, we're going to add 3 to both sides. And we end up with a new equation of 4x squared minus 12x plus 9 equals 0. And we are right back to our quadratic formula. A equals 4, B negative 12, C equals 9. Plug it into the formula. X equals negative 12 plus or minus the square root. Negative 12 squared minus 4 times 9 all over 2 times 4. So we get x equals 12 plus or minus the square root of 144 minus 4 times 9 is also 144 all over 8. Well, what is 144 minus 144? 0. Hey, if our square root is a 0, how many solutions do we get? Well, if our square root is 0, that means we have a 0 right here. And if you have a 0 right there, if you do 12 plus 0, that's 12. And if you do 12 minus 0, that is still 12. So you don't have 2 solutions, you really only have 1 solution. Your solutions end up being 12 over 8. Which 12 over 8 is the same as 1.5. So the only x value where they're going to cross is going to have, sorry, the only ordered pair where they cross is going to have an x value of 1.5. How do we find the y coordinate? Well, we're going to take the x and we're going to plug it in. Again, it does not matter which of the 2 equations I plug it into. Let's see. I don't like that this one's a negative, so I'm going to plug it into this one. So I've got y equals 2 times x squared, so 1.5 squared, minus 7 times 1.5 plus 6. Kind of running out of room there. I'm also going to grab a calculator because I want to make sure I double check my work here. So I've got 1.5 squared, which I believe is going to be 2.25. Yup. So y equals 2 times 2.25. And then 7 times 1.5. So minus 10.5. What does that say? Plus 6. Sorry, this is a little sloppy here. 2 times 2.25 is 4.5. Then we have minus 10.5 plus 6. 4.5 minus 10.5 is negative 6. And negative 6 plus 6 is 0. So my y coordinate is 0. Which means when those 2 graphs cross, they will cross at this point and this point only. And here we go, here's a picture of it. Sorry if it's a little hard to see, but we've got one parabola opening down. We've got a second parabola opening up, and they cross right there, which is the ordered pair 1.5, 0. This is some good stuff right here. Good review too. All right, one last problem for today. Again, we have 2 quadratics. We're going to set them equal to each other, or substitute one into the other equation. 2x squared plus 3x plus 5 equals x squared minus 4x minus 7. What do I need one side to equal? I need it to equal 0. So I'm going to move my smaller x squared. Subtract x squared on both sides. Going to add 4x to both sides. And then I'm going to add 7 to both sides. And that gives me a new equation of x squared plus 7x plus 12 equals 0. Perfect. A equals 1, B equals 7, C equals 12. Plug that into the quadratic formula. X equals -7 plus or minus the square root 7 squared minus 4 times 1 times 12 all over 2 times 1. I love the quadratic formula, it's so good. -7 plus or minus the square root of 49 minus 48. Go ahead and write it down. 49 minus 48 all over 2. 49 minus 48 is 1. And what's the square root of 1? Well, it is a regular 1. So now we've gotten all the way down to -7 plus or minus 1 over 2, which is the same as -7 plus 1, so -6 over 2. And -7 minus 1, which is -8 over 2, which simplifies. -6 over 2 is -3, and -8 over 2 is -4. But again, that's just what x equals. We have found the x coordinate of both solutions. We know that the x coordinate of one solution is -3, and the x coordinate of the other solution is -4. Now we've got to go back and do some work, right? We got to do some algebra here. We're going to plug in -3 into either equation. I'm going to go ahead and choose this second one. Looks a little bit more simple. So I'm going to do y equals -3 squared minus 4 times -3 minus 7. So that's 9 plus 12 minus 7. 21 minus 7, 14. So -3 comma 14. Again, if I'm going too quick right here, we're just taking the x value and we're plugging it in for the two x's, right, in one of the equations and then simplifying. For my second one, I'm going to do the same thing, but I'm going to plug in -4 instead of -3. So -4 squared, right, x squared, -4 squared, minus 4 times x, so times -4, and then minus 7. And as we simplify this, -4 squared is 16. -4 times -4 is also 16. And so we get 32 minus 7, which is 25. So our solutions, -3 comma 14 and -4 comma 25. Again, big picture. What does this look like on a graph? It looks like two U-shaped graphs that cross at this ordered pair and that ordered pair. And that is all for today. You did it! Have a great day.